What we're going to look at today is the vertex form of a quadratic. What you should do, if you haven't already, grab out your MJ. I'm going to give you some new formulas that you'll want to record as we go along. I apologize about the fuzziness, but I just kind of copy and pasted from your textbook so you can follow along. It's from 8.4b. The vertex form of a quadratic function is y equals a times x minus h squared plus k. And similar to standard form, a cannot equal 0 for obvious reasons. If a were to be 0 and it was multiplied by all of this, when you multiply something by 0, ends up canceling it out, and you'd only be left with k. If you're only left with the constant, doesn't involve this square right here, then you don't have a quadratic anymore. Similar to what its name says, vertex form will show you what the vertex is of a quadratic. So the x coordinate comes right here from h, and the y coordinate comes from k. One of the best ideas, or the nicest things about vertex form, is that you can tell what happens, the characteristics of a graph based off of the formatting. So if you just have a basic form like this, so I've taken away a and I've taken away k, if h is greater than 0, then it moves to the right. Okay, that's that red one right here, of x squared. X squared is just going to be your basic parabola right through the center of the origin, with the line of symmetry being the y-axis. When h is less than 0, then it's a horizontal translation to the left, however many units that is. So let's do some examples. This will make more sense. Essentially, this h then tells you which direction the graph is moving. Example number 1 looks like this. Graph x minus 4 squared. And then compare the graph to y equals x squared. First thing that you'd want to do is to make a table, just like regular. It is 0 through 8. You can see your y coordinates. Step 2, you plot them, and then draw your curve through it. The black line is your x squared. The blue line is your x minus 4 squared. Now, you'll notice that it got translated over 4 units to the right. What that means then is almost, I like to think of it as the opposite. So when it says x minus 4, you're actually going to the right 4. In the previous slide, I talked about if this h was less than 4, or sorry, it moved to the right. Let's see. Oh, is when h is greater than 0, meaning that h must be a negative number, which means would times by another negative changes it to a positive. In this case, the 4 then was a positive 4 being subtracted, and therefore moved it 4 units to the right. If it would have been x plus 4, then I would have moved it 4 units to the left. Second example is what happens if I have this k on the end. How does this k affect what can you see from the graph? First off, x plus 5 squared minus 1. From our previous example, this would tell us then, because this 5 ends up being a negative, because the original format, remember, was a minus h, and so when you're minusing a negative, it changes it to a positive, and therefore we're moving it to the left 5 units, or think of it as the opposite. So this is our original, we move left 5 units. Now this is different. It's not right on the x-axis, it moved down 1. Can you see where that is shown in this equation? You are correct. It is the k, which is showing you the direction of the translation, whether it's going to be up or going to be down. Don't get this confused with our y-intercept, and we'll talk about that in just a moment. This is just simply, in this form, talks about how the graph will move, whether it's moving left or right, and up and down how far. Finally, what happens if I throw a number in front of the parentheses, to which they called a? So the negative 2 times x plus 2 squared plus 3. So So let's think about what we're combining essentially everything we've done so far. Look at the inside right here, x plus 2. Well, that's going to tell me then, think opposite, it's going to move 2 units to the left. Let's check it out. Started here, moved 1, 2, and there it is, moved 2 units to the left. The plus 3 then, this k tells you whether it's translating up or down and how many units. The plus 3 tells me it goes up 3. 1, 2, 3. This here is where you can tell what the vertex is. Way back at the first slide, when I go back here, the vertex right here is h comma k. Let's see if how that shows right here. Go back to this one. The vertex, write it, h comma k, based off of our equation. This h then, remember, it's a little bit tricky because the original equation was a minus. So what does h have to be in order to change this minus into a plus? You're right, has to be essentially a double negative. So h then is a minus 2. The k then is just whatever's hanging out at the back here, 3. So my vertex in this case is -2 up 3, which you can see that's exactly where my vertex is. These are some of the great ways of why the vertex form is nice to use and just a different formatting. If you would like more practice with this, there are some on your own practice problems that are in your textbook from lesson 8.4b from pages 432 and 433.